Yeah, like, why waste your time? So, what we'll learn, it's called the half-reaction method for balancing. Well, that's super dark. Is that too dark? No, never too dark, is it? All right. Benson, is that seat taken? All right. It's weird. Our two kids that don't ever come are right here. Yeah, weird. All right. So, to balance an oxidation-reduction equation, it is, once again, super tricky sometimes. This involves treating on paper only, so it's not really two different reactions in chemistry, but whatever. Oh, I just about punched you. That was bad stretching timing. The oxidation and reduction is two separate processes, balancing these half reactions, and then combining them to attain the balanced equation for the overall reaction. Okay, I'm going to put up what the steps are. All right, so here are the first two. Assign oxidation numbers to determine what is oxidized and what is reduced. Write the oxidation and reduction half reactions. I will come back. Let me just see if they're also here. Okay, they're not. So I'll pause it. So here's some more. So after we have the half reaction, we're going to balance it. To do so, we're going to balance elements other than hydrogen and oxygen. Then we'll balance oxygen by adding water. Then we're going to balance H by adding H+. Then we're going to balance the charge by adding electrons. Then we're going to multiply half reactions by integers so that the electrons gained and lost are the same. And this is still not all of them. So these are just like double checking. They're not steps. They're just like, hey, make sure you didn't screw up. All right, consider the reaction between MnO4- and C2O4- 2. Okay, this should be subscript. Hold on, let me fix this real fast, if I can. Or superscript, I mean, not subscript. I'm hitting that. Tell me I'm not pressing that button. You're all lying. I am. Okay, I did. Straight to your face, in fact. Wait, you're a liar. Okay, is that better? Okay. By the way, when we talk about oxidation reduction, oxidation numbers are typically written 2 minus versus -2. It does not matter. And my entire life, I've done the sign and then the number. And it's fine. You'll see here they put 2 minus, but whatever. It's the subtle difference between charge and oxidation number, but we're fine. Okay, so here we go. This is our example. I think it goes through it piece by piece. First, we assign oxidation numbers. All right. Oh, this is just a disaster. That's an arrow. What? That's... Because of how it transfers. No. It's an arrow. This is just hideous. Okay. When we assign these numbers, oh, this is a 4, and it's a -1. You got it now? Like, it's kind of hideous, but we'll move on. When we assign these, oxygen's always a -2, so we took the -2, we multiplied it by 4, and we subtracted 1. All right? So, well, okay, yeah, so we get 7. Okay. Okay, hold on, let me just do it together. We know this equals a -1. You okay with that? Yeah, the overall thing, that's what this piece tells me. So all these pieces add up to a -1. Oxygen, when we find oxidation numbers, is always a -2. So we have to account for all of these, so that's a -8. All right? Something -8 equals a -1. So that is a +7. When I said it before, I said 8 minus 1 gave us a 7, which in my head, that made sense. But yes. All right? So you find what its overall charge is. account for the knowns, which oxygen is always a known because it's the most electronegative unless there's fluorine around. All right, so it is always what it wants to be, and it forces the other thing to be something else. That's where the +7 came from. The +3 comes from the same concept. We have C2O4 -2. All right, oxygen is a -2 times 4 is a -8. Something -8 equals -2. But look, there's 2 of them. So this is a 6, makes this math work, right? But the 6 must be divided by 2. So that's where the +3 came from. Okay, those are like tricky. Remember how I said you have to be good accountants? Nothing's very hard right there. You just got to make sure you do an account for every part. All right. Then over here, manganese went to a +2 because it told me to. That's what this scribbled out part was. And then C, this is off. That should be pointing at carbon. C goes to a +4 because you have the 2 times -2 is -4. So something -4 equals 0. And that's where the +4 came. Okay. Now, I'm going to clear all this out so we can read. Since the manganese goes from +7 to +2, it's reduced, which means it's made to be more negative. Now, I know it's +2, but +2 is closer to negative than +7. Oxidized means it becomes more positive, and it did that, +3 to +4. Okay, so we're going to write out these two half reactions. So, C2O4, and I know what I can do. I think. Let me just fix these with a mouse. About that. So we got to balance the carbons, essentially, is the first step. And let's just do it all on this page. So we add a 2 in front of carbon dioxide to balance the carbons. So we did that. What's the next rule tell us to do? All right, balance H by adding H+. There is no H, so we don't really need to do anything there, right? What's the next one? What about our oxygens? All right, I balance oxygen by adding H2O. Do I need to do that? No, I have 4 oxygens and I have 4 oxygens. We okay with that? This one's, it's easy so far, sure. It's okay. So what's the next step? All right, balance charge by adding electrons. So I have a -2 here. All right, I got to double check this before I say it wrong. Hold on. All right, since we have a -2 here, we're going to add 2 electrons to this side. Okay, that makes both sides a -2, or the overall 0. We okay with that? Okay. What's the next step? That's it for now, right? We have to move to the other. So this was the oxidation half. We now need to move to the reduction half. Are we okay with that? Okay, so we'll come up to that one. All right. So the manganese is balanced. To balance the oxygen, we must add 4 waters to the right side. Okay? And we can do this because this stuff is happening in an acidic solution. And if it's in an acidic solution, it means there's plenty of H+, and it also means there's water around. So it can use this H+ and water as part of the actual reaction itself. Okay. So we add the 4 waters to account for the 4 oxygens. What's the next step? Balance hydrogens by adding what? H+. How many H+ or hydrogens are there? 8. 4 times 2. So I'm going to add 8H plus. Okay. What's the next step? All right. Balance charges by adding electrons. Okay, so what's my total charge over here? Seven. Plus or minus? Plus 7. And what's my total charge over here? Plus 2. All right, this is the reduction, which means you gained electrons, right? All right, so I'm going to put them over here. How many electrons do I need? Whoops, I should have put that up there, but whatever, we can just move that. Okay. Don't move like you normally do. I got to sneeze. Now, these parts, this is not on there. What's the next step? Is it time to combine? All right. So now I have to combine them because it says multiply half reactions, correct? All right. I think I have them combined on the next slide. No, I don't. There we go. Here we go. So it's ugly, but just stick with me here. So I have 5 electrons on one side, but I have 2 electrons on the other. They have to be equal. The electrons have to cancel out. So I take the one that had 2 electrons and I multiply it by a factor of 5. I take the one that had 5 and I multiply it by a factor of 2 so that they both equal 10 now. Okay? To attain the same number of electrons on each side, we multiply the first by 5 and the second by 2. Now, I don't just multiply the electrons by 5. I multiply everything by 5. So there'll be 5 of these, 10 of these, 10 of these. 10, 16, 2, 2, and 8. Did I do something wrong? Okay, I often do. Okay, so once we've done that, we end up with these 2 that we now add together. So here's all the reactants. Here's all the products, and we add them together, and we get this. 10 electrons plus 16H plus 2MnO4 minus plus 5C2O4 2 minus goes to 2Mn plus 2 plus 8 waters plus 10 CO2. And then the final step is to cross out anything that's the same on both sides. Your electrons always have to cancel out. If they don't, then you screwed up and you need to go back to start. All right? That's not good. But then everything else is left over. So this is your balanced reaction. On the multiple choice section of the AP test, you will get one of these and it will just say, like, what is the coefficient in front of water? And it'll just be A, B, C, D, E. It'll be 2, 4, 6, 8, 10 or something like that. So you'll do all this work for that coefficient. Now, can you see why I want you to skip it in the multiple choice? It takes a long time. Is there anywhere in here we could have screwed up? Yeah. So I honestly think to your own benefit, unless you have time at the end to go back, you should just guess a number and move on. But in the free response, you're going to need this for other things, and you can get partial credit. So you should do it. Okay. Did someone say, can we do another one? Always has to say this, by the way. It may say basic solution, and we'll learn how to do that here in a few minutes as well. And it's mostly the same, so don't panic. All right. So what's your first step? Nope. You find the numbers to find out which is oxidized and which is reduced. So do that. And oxygen is the boss. It's like the older brother or sister that tells you what to do and you can't do anything about it. You don't like it, but you still got to go clean your room. Pretty much. So that's why it makes N become positive. And you know what? N's actually not that bad. It would have rather gained 3, but honestly, if it comes a plus 5, it met its octet rule anyway. It just did it by abandoning its outer shell completely. It acts more like a metal here. All right. So I'm going to get rid of this because we're going to need this space. But that's how you got the plus 5. Okay, now, chlorine becomes from plus 1 to 0. So did it become more positive or negative? All right, if it becomes more negative, it is it's what? Didn't mean to give that away. Reduced. And so this one's oxidized. So I'm going to write these out. I'm going to say Hochul, all right, goes to Cl2. You okay with that? And I know that's weird. Jeffrey didn't like it. Like, what? Where's the O and the H? Well, they're taken care of eventually. But this is where chlorine changed. Okay? And then I have the other one. We'll write it lower. NO goes to NO3 minus 1. We okay with that? And I should have centered these more. Okay. And then we're ready to start following other rules. So now that we have these, what are our next steps to do? Okay, well first, balance anything besides H and O. So we got to balance chlorine. There's 2 on the right, so I'm going to double this. Okay with that? So first, balance things that are not hydrogen and oxygen. What's the next step? I balance the oxygen first. Because if I do H first, then I'm going to have to add water to change the O's anyway, and it's going to screw up the H's. All right. So I need to add what over here? 2 H2O, because there's 2 O's, right? All right. Now I have 4 H's over here, so I need 2 H pluses over here. Okay, and this part is my reduction, correct? This is my ox. Okay, so what's left? Charges. Okay, if I'm reduced, that means I gain electrons, correct? That means they're on the left, so plus 2 electrons. And now my charges are balanced. With me? Who's with me? Okay, that's... Okay, look. The overall charge has to be 0. This was a plus 2. There was 2 pluses. So this side was plus 2. All right. Since I'm reducing it, reduction is the gaining of electrons, which means they need to be on the reactant side. You with me? So if I have a plus 2, that means I need a minus 2, and the way to get that is through 2 electrons. The what? No. Because this isn't part of the reaction. This is the thing reacting. Okay, we don't have to worry about the oxidation charges up there. Okay, good questions there. All right, so this is now balanced according to charge and mass. I don't know what's going on out there, but it sounds funner than what's going on in here. But that's pretty much every day, so I'm used to it. Okay, now we're down to the oxidation. What do we do now? Well, first balance N's, and they are, correct? Next thing is to balance what? O's. So you need 2 more, right? So you need 2 H2O. Then what do you balance? plus 4H plus. Okay, what else now? Charges. Okay, so let's look. We have this time Kitzel. This does matter because it was written in the actual equation itself. See the difference there? Okay. So over here now I have a -1 but plus 4. Are we okay with that? So I have an overall plus 3. Is that fair? I have to get rid of that. Since this is an oxidation, it loses electrons, right? So that means it's a product, so I need to add 3 electrons. Now, if you put the electrons on the wrong side, it doesn't really matter, because you're going to put them on the wrong side on the next one, and they cancel out anyway, right? So don't stress too much on whether we put them here or here, but just make sure they're on opposite sides. That's all that really, really matters. Okay, now what do we have to do? I have to balance here, right? I can't have the charges not be equal. So a 2 and a 3 will equal each other if you make them become a 6, correct? So this one needs to multiply by 3. This one needs to multiply by 2. Okay, so I'll rewrite this. So check me while I write it. 6H plus 6HOCl plus 6 electrons goes to 3Cl2 plus 6H2O. Did I do all that math right? All right, 4H2O plus 2NO goes to 2NO3 minus 1 plus 8H plus 6 electrons. Now, I'm going to add these. Okay, here's my arrows. So I'm going to add these parts. All right. So I now end up with my overall reaction is all this stuff. Now, are you okay, just to save some writing now, I'm going to cross these out. Okay, they are equal. So now I have 6H plus 6HOCl plus 2H2O plus NO goes to, and I'm going to come back up here. Oops, sorry, a 2. I don't know how I come. Oh, I just read this one, didn't I? 4H2O. All right, it's kind of ugly. I better fix that. I'll lose some friends for real. Oh, okay, never mind. There we go. I'm adding this one and this one. And then I'm adding this one. That's before I balance the charge. It is, like, if I could zoom out and show you all this, it makes sense, but it is kind of tricky the way it's written, I guess. Okay, so now one more time up here, 3Cl2 plus 6H2O plus 2NO3 minus plus 8H plus. All right. Then I'm still not done. Now I can cancel crap out that's on both sides again. And you could have done that before this. I just wanted to be super thorough. All right. So typically the H pluses and the H2Os, they don't cancel out, but they reduce. You okay with that? If I have 6H plus on the left, but I have 8 on the right, in reality, I only have 2 on the right side. Are we okay with that idea? Okay, I'm going to cross those out now. Plus, the only other things that usually cancel out are your waters. I have 4 waters on the left and 6 waters on the right. So that really is 2H2O. Yeah, you definitely can. Okay, then I just write this. And we should be good to go as long as we accounted for everything. 6 Cl, 6 H's, 6 H's, 2 N's, 2 N's, 2, yeah, sorry, well, you got your 6 plus 2 more is 8. You have 2 plus 6 more is 8. It is balanced. How fun was that? Did anyone secretly enjoy it? I like it. It takes forever, but I feel good about it when I'm done. What's what? This? I have no idea. Oh, hold on. Yeah. This couldn't be more confusing.